Okay, we're going to practice using our tan theta ratio to solve for sides and angles, and we are going to be pretty explicit in terms of laying out the work like we should when we start out, and to make sure everything works out nicely. So we'll start with this one over here. We're looking for the alpha angle. That's Greek letter alpha right there, so we're looking for that angle right there. So tan alpha would be equal to opposite divided by adjacent. The opposite would be, on the opposite side, would be the 56. The adjacent is the one touching it right there, so that's the 24. So we got the 56 divided by 24, so I'll punch that out. 56 divided by 24 gives us 2.33. So then to find the actual angle, I need to take the inverse tan of that 2.33, and that will give me my angle. So I inverse tan that answer, and it tells me I got an angle of around 67 degrees. All right, so there's that one. Okay, let's try the next one. This one, we're looking for angle beta, another Greek letter right over there. So again, we'll lay this out. So tan beta would be opposite divided by adjacent. The opposite is the opposite side, so 20.8. The adjacent is going to be the 23.2. So I'm going to do 20.8, divide that by 23.2, and it gives me a ratio of 0.897. So then if I actually want to find the beta angle, that'll be the inverse tan of that value. So I'll just take that 0.897 and I will inverse tan that answer. And we get an angle of 42 degrees, so 42 degrees, something like that. All right, so the next two, we're looking for sides. Now we're going to do something interesting, find sides over here. So I've got the 39 degrees over there, so I'll be using that. So I've got the tan of 39 degrees is equal to the xz, the opposite. That's over here, the opposite. So that's xz divided by 3.9. And if you want, you could punch out the tan of 39. So if you do the tan of 39, if you want to use a decimal instead, that is 0. Well, we'll just say 81, so it's 0.81. So you could do that instead of the tan 39 if you want. So this is what we're looking for. So what we'll do is we've got to multiply both sides by 3.9. We'll times this side by 3.9 so it cancels, and then times this by 3.9. So xz would be 3.9 times the tan of 39 degrees, or just you can put 0.81 if you want instead of tan 39, but it doesn't really matter. So if we do 3.9 times the tan of 39, we will get a side of approximately we'll round off, of course, we're around 3.2 feet in this case. So this is 3.2 feet. Okay, and there's different ways you can actually solve this. It's basically a cross-multiplying dividing thing. So you just cross-multiply tan 39 times 3.9 divided by the invisible 1, and it gives you this. So this where cross-multiplying can come in handy to solve for these as well. Okay, so let's try the last one on this page. We're looking for DE. This is what we're looking for. I've got the 46 here, so I'm just going to set that up. Tan 46 degrees is going to be equal to the opposite, which is the DE, which is what I'm looking for, divided by my adjacent, which is the 7.4. So we can just cross multiply. I mean, this is tan 46 divided by the invisible 1. So if we want to solve for this, we could cross multiply. So tan 46 times 74 divided by 1 is easy. It should give you this. Some people just like doing the cross multiply way. It doesn't really matter. So if we do that, we can take the tan of 46. Good idea to press equals after you do that. Then take that answer, times that by 7.4. Okay, and then divide that by the visible 1, which really doesn't mean anything. And we get a DE of approximately 77 meters. So this is 7.7. so 7.7 meters. Okay, so there's some tan theta examples right there. So let's look at another 4. Okay, so here's another 4 questions to look at. Again, we'll just be doing the same thing using our tan theta to solve for things. So for the first one here, we look for angle alpha or angle PRQ. I just like using the alpha. I just find that a lot easier. So we are going to look for what the alpha is. So tan alpha is going to be equal to the opposite, which is 60, divided by the adjacent, which is 40. So 60 divided by 40. And we can solve for the tan theta. So 60 divided by 40, that's just 1.5. So then I would want to take the inverse tan of 1.5. That will give me the actual alpha angle. So if I take the inverse tan of 1.5, I get an angle of, alpha is going to be equal to around 56 degrees, something like that. Okay, we'll do the next one here. Look for angle beta. So tan of angle beta, there's my beta right there, is going to be opposite over adjacent again. My opposite is going to be the 24, it's opposite side, divided by my adjacent of 44.8. So 24 divided by 44.8 gives me about 0.536. So then to find my actual beta angle, I'll take the inverse tan of 0.536. So I'll take the inverse tan of that decimal I got, and I get an angle of around 28 degrees. So that'll be 28 degrees, something like that. Move that back up a little bit. No. Okay, so that is that one. There you go. That's better. Okay. All right, so let's try the next two. We're solving for sides again. So I'll start with this one over here. I'm looking for side AC right there. All right, so I got the tan of 45. So tan of 45 degrees is going to be equal to the opposite, which is 40.5, divided by the adjacent, which is line AC, which is what I'm looking for. So you can do cross multiplying if you want for this. It will work pretty nicely. Of course, this is over an invisible 1. So if I do 40 times, or 40.5 times 1, and then divide that by the tan theta, it should give me my AC. So cross multiplying is one way to do this. Or you can just do 40.5 divided by tan 45. It's all going to work out okay. So if we do the 40.5 divided by the tan of 45, we will get 40.5. AC is equal to 40.5. 40.5. Now, there's no magic for this one that those two are the same. If you see 45 degrees, one of the great things about 45 degrees is that these two sides are going to be equal to each other. But we calculate it anyway just to practice doing the actual calculation. But with 45 degrees, the adjacent and the opposites are going to be equal to each other. Okay. All right. Now let's try the next one over here. We're looking for this one right here. We got 38. So I know I'm going to be using the tan of 38 degrees is going to be my opposite, which is xy, divided by my adjacent, which is the 39.9. So again, we can cross multiply if you want over invisible 1. What we can do is tan 38 times this divided by this, which is this. So it's basically going to be tan 38 multiplied by 39.9 to give us our xy. So tan of 38, I'll get that first, and that's like 0.78-ish, times that by 39.9, and if you want, you can divide by the invisible 1, doesn't make any difference, and we get about 31.1, or if you, well, 31.17, so maybe 31.2. So xy would be around 31.2 yards long. Okay, so there's some examples on how to do the tan function and tan ratios and calculations.